Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, sum of left leaves. So essentially what we are asked to do is we get a binary tree and we want to return the sum of all the left leaf nodes. So only the left ones that are leaf nodes. So for example, what that means is for this one, we want to return this left side and this left side. So that gives us 9 plus 15. And so we return 24, right? And we don't count the right side. So pretty straightforward. Now, whenever you have something like this with where you need to traverse binary tree, you should think about doing either DFS or BFS. And here, DFS should be very straightforward because we can just keep traversing, right? All the way until we reach a node that is on the left side that doesn't have any children. So we go to the left side here. It is a left node. It doesn't have a left child or right child. So we return 9. And then we go bubble up. We go to 20. It does have children. We go down. We go to 15. It doesn't. So we add 15. We go to 7. It's a right node. It doesn't have any children. So we stop here. Now, you notice here we said we need to know whether this one is a left node or not. And we need to know it at that node because we need to check the node if it has a left child or a right child, if it's a leaf node or not. So, but the parent knows, right? So before calling the child, we can just pass a flag saying whether it's a left or a right node, right? And that's pretty much it. Whenever you have an information that the child itself doesn't have, but the parent has, you can just pass it in the parameters of the child, of the function called for the child, right? So what does that look like? So we said we need to do some sort of DFS recursion, and we need the node, and we need to pass the information on whether the node is left or not. And we can kick off the call with a call to root. Initially, the root node is not a leaf node, so we pass false. Now, if we reach a leaf node, if we reach the end, so we recurse it and there is nothing, we return just 0. But essentially, we do know we want to call on the left side and we want to call on the right side and get the sum of the left leaves of each. Now, this is the left side, so is left should be true. This is the right side, so is left should be false. Now, how do we handle the leaf left node? Well, what is the left node? Well, first it needs to be a leaf. And then needs to be on the left side, so is left needs to be true. And so for it to be a leaf node, we need it to not have any children. So it doesn't have a left child and it doesn't have a right child. And we need it to be a left node. So that's what we pass here. Now what should we return? We need to just take the value because at the end what we want to return is the sum of all the left leaves. So return node.val. So there is a typo here. We need to do not node.right because we need both to not be present for the node to be a leaf node. Okay, let's submit, and that passes. Now in terms of time complexity, it's going to be just the number of nodes because we traverse each node. So it's going to be O(n) time. In terms of space, we recurse and we keep in the stack of the recursion each time the children of one node, and so that means basically starting from the root. So that means it's the height of the tree for the space complexity. Yeah, so that's pretty much it. Thanks for watching, and see you on the next one. Bye.